Okay, let's look at how do we look at bond length and strength and the calculations related to it. So if I look at a molecule like this one here, then I know that to break this bond, it's a single covalent bond, I will need less energy to break it. Why? Because this is a single covalent bond. So the bond between carbon and hydrogen will not be a very high bond. I won't need a lot of energy to break it. However, to break the bond between carbon and carbon where there's a triple bond, I will need much more energy because it is a triple bond holding them together. Also remember that because this is a triple bond, the two carbons here will be much closer to each other than, for example, the two carbons here, because between these two carbons there's a double covalent bond. So although it's a bond between carbons, these two carbons are going to be close together. Why? Because of the triple bond. Triple bonds means shorter bonds and more strength. So these two carbons are going to be further apart. Why? Because it's a double covalent bond between them. It's weaker and they will be further apart. Right, so let's look at how do I calculate how much energy. Remember I said to you, to break bonds I need energy. To make bonds I need energy. So we can calculate this energy. Now if you are given a molecule and you have to calculate how much energy will you use to break these molecules. So we look at these two molecules. You will be given a table, and on the table you will be given a couple of combinations of bonds. Now please note that this table will have more than the bonds that are depicted in the molecule. So please don't use the table and think, oh well, all these bonds must be in the molecule. No, they're not. Look at this one. There's only a carbon hydrogen bond and there's only a carbon triple bond between them. So you have a carbon single hydrogen bond and you have carbon triple bonds. You don't have any of those other bonds, but you need the table to do the calculation. Right, so we'll put the table one side and let's go look at the first molecule. So if I look at carbon hydrogen bond, I see that I have two of them. This one here and that one over there. So I have two carbon hydrogen bonds. If I go to my table, I see that a carbon hydrogen bond, to break one of them, is 416 kilojoules of energy. Please note it's in kilojoules. So that is where I got the 416 from. So I have two bonds of 416. Then carbon triple bonds. If I look at my table, I see that a carbon triple bond needs 839 kilojoules of energy. So my carbon triple bond, 839. So these two bonds here plus the carbon triple bond gives me 1670 kilojoules per mole. This one here is a little bit more complicated. Now you can write your bonds out, and the best way of doing this is to actually write your bonds out and then mark them off on your table. So I'm not going to use my molecule for that, but I will do an example molecule with you in a separate lesson. So let's just look, what did I do with this molecule? I went and looked up the carbon hydrogen bond and I saw it's 416. Then carbon double bond oxygen, 745. Carbon oxygen single bond, 538. And then oxygen hydrogen single bond is 467. In this one you can see that all my bonds are not repeated. So I looked up all the bonds, then added them together and got my answer. So my 416 was between carbon and hydrogen. My 839 was between carbon and carbon triple bonds. So in my next lesson, I'm going to show you what is a better way of doing this, how to do this when you get it in an exam, because myself and Ms. Shamina has a suspicion that you are going to get a far more complicated molecule than the one that we have over here.